Okay, so right, let's go over the announcements first. So this week in class, we'll be going over two different sections. So this is going to be sections 8.1 and 8.2. So 8.1 was assigned for Tuesday. And please go ahead and make sure you look at 8.2 starting today. And the idea behind 8.1 is we just want to go ahead and introduce polar coordinates. And we do this by first reviewing rectangular coordinates and then translating rectangular coordinates. So there's a lot of weird things going on with polar coordinates, especially when we start to graph it. One stark difference between polar coordinates and rectangular coordinates is that when you have graphs and rectangular coordinates, they never have self-intersections. But polar coordinates have graphs where you have tons of self-intersections. And in 8.2, we start studying these types of graphs. And we're going to be looking at polar functions. Let me go ahead and note too that whenever you're listening to 8.1 and 8.2, there was an audio problem. So 8.1's really quiet. The first two sections are also really quiet in 8.2. So when you go from part B to part C in 8.2, turn your volume down or your ears are going to get blasted. I just wanted to give you a heads up so you don't go deaf. Now, this week, we'll be looking at quiz 8. And this is really the core of what we study when we're looking at trigonometric equations. So these types of equations that we introduce are in 8.4 and 8.5. So these are going to pop up in a few different places. So if you ever study harmonic motion, or if you study any kind of vibrational system, you'll definitely see trig equations. So in other words, you'll see them in physics. So this is a normal quiz. It's released today. The due date is Friday at 5 p.m. And you'll have one submission. You'll have about 60 minutes to finish the quiz. If you have questions about any of the problems before you take the quiz, just send me an email and we can discuss those. And the reason why is because solving trigonometric equations is definitely a non-trivial thing. There's a lot of different ways to do it. But not only that, even just writing down the solutions can sometimes be enigmatic. Sorry, I can't say that word right now. Mysterious. So anyway, let's go on. Before we start looking at any problems, does anyone have any questions about the final grades, anything like that? No? Good.
When is that thing you said yesterday?
Oh, the write-up. So it's going to be due Tuesday. I think that's November 10th. Okay. So we'll be looking at solutions to the in-class activity, and we're just going to go ahead and start with problem number 1. And what we want to go ahead and do is we want to solve the following trig equation. So this is going to be sine theta is equal to the square root of 2 divided by 2. So really, this problem is going to be a fundamental problem because we're going to solve every trigonometric equation following this pattern. Once we have a trig equation in the following form here, we need to do two things. So number 1, we're going to find a particular solution. And this is just another way of saying just find any solution. And then number 2, we're going to find the general solution. And the general solution is going to come from taking your particular solution and adding some multiple of 2 pi to it. Or if it's tan, add a multiple of pi to it. So we can go ahead and solve this equation. There's a few different ways. I personally like drawing pictures because that always helps me visually. So let's go ahead and draw a picture here. So two things that we know is that we can form a right triangle based on this equation here. And the other thing that we know is that sine theta is positive only in the first and second quadrant, which means that we only have 2 quadrants where we have solutions. So it's either going to be in the first quadrant or the second quadrant. So we can form a right triangle whose acute angle with the x-axis is given by theta. This means the opposite side is going to be the square root of 2, and the hypotenuse is given by 2. And we can form a mirror triangle in the second quadrant, again, whose acute angle with the x-axis is given by theta. So this is square root of 2, and this is 2. So real fast, if we wanted to find this side here, how do we do this? Yeah, so we just want to use the Pythagorean theorem since we have 2 sides of a triangle. And this is going to tell us that, let me go ahead and write that down. So we have the pi theorem, which is again a squared plus b squared is equal to c squared. And so our a is going to be equal to the square root of c squared minus b squared. Plugging in what we know, we'll get a is equal to the square root of 4 minus 2, which is equal to the square root of 2. So a is the square root of 2 in both cases over here. And so that tells us we have a 45, 45, 90 triangle. So our theta angle in this picture here is going to be given by pi divided by 4. So this is the part where I just need to be a little bit careful in explaining what's going on here. So remember, pi divided by 4 is this angle right here. But pi divided by 4 represents a reference angle for the blue triangle. So to find the actual angle, what we're going to do is subtract pi divided by 4 into pi. Because we're really looking at this angle here. So the solution to number 1 is going to be our theta is either equal to pi or it's equal to pi. Oh, I'm sorry. This should be pi divided by 4 and pi minus pi divided by 4. So before we move on to step number 2, is there any questions about this? Oh, yeah. So if you wanted to use the unit circle, if you're more comfortable using that, you can go ahead and do that. It's really up to you. Okay. So we found the particular solution, and really, again, the general solution is just we're going to add plus 2 pi k to each of these terms here. So our general solution will have 2 types. Either theta is going to be equal to pi divided by 4 plus 2 pi times k, or theta is going to be equal to 3 pi divided by 4 plus 2 pi plus k. And remember, the reason why we're adding this 2 pi k here is because sine's a periodic function, which means it repeats its values every full period. And so a period is given by some multiple of 2 pi, and that's why these are also solutions to this equation. Okay, so this would be the final answer here. Okay, let's move on to the next question. So example number 2. Now we want to go ahead and find all solutions of the equation 2 cosine squared theta minus 1 is equal to 0. So this problem looks slightly more difficult than the last one, but really there's only one extra step that we have to do here. And what you want to think about is this looks like a polynomial. So we have, if we wrote a polynomial that looks like this would be given by something like 2x squared minus 1 is equal to 0. And if we wanted to solve an equation of this type, all we'd have to do is solve for x. So solving for x over here, we would get something like, what, 1 divided by 2 is equal to x squared. And so we're going to do the same thing to our trigonometric equation. We're going to solve this like we would a polynomial. So solving for our cosine squared theta, we'll get cosine squared theta is equal to 1 divided by 2. Taking the square root of both sides, we get cosine theta is going to be equal to a plus or minus square root of 1 divided by 2. Let's go ahead and simplify this. This is going to be equal to plus or minus 1 divided by the square root of 2. And so we have to solve two equations this time. So in part A, we need to find all the values where cosine of theta is equal to 1 divided by the square root of 2. And in part B, we need to go ahead and solve cosine of theta is equal to a negative 1 divided by the square root of 2. So we'll go ahead and solve part A real fast. Again, cosine of theta is positive in the first quadrant, but now it's also positive in the fourth quadrant. So we can form two right triangles, one in the first quadrant, whose acute angle with the x-axis is theta. This has an opposite side of length 1, hypotenuse of square root of 2. And we can do the same thing in the fourth quadrant. This has angle theta for the acute angle with the x-axis, opposite side of length 1, and square root of 2 here. Let me go ahead and note that this is actually a negative 1 here. Okay. Oh, I'm sorry, this is cosine, so it's not opposite side. This should be adjacent side here. So this is 1 here, and this is 1 here. So again, if we want to find the other side here, we're just going to use the Pythagorean theorem. And so what we're going to get, let me just call this side B real fast. B is going to be equal to the square root of 2 minus 1, which is equal to just 1 here. So this is equal to 1, and this is equal to 1. And again, what this tells us is that the angle theta is going to be pi divided by 4. So theta is going to be equal to pi divided by 4. And also, again, the theta right here is a reference angle. And so the actual angle that we're looking at is given by this here. And so we need to subtract 2 pi by pi divided by 4. And we'll get our other solution is 2 pi minus pi divided by 4. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So we'll hold on to these solutions and then find a general solution. Let's go ahead and do the same thing for this over here. We won't cover all the gory details like we just did, but again, basically, we're looking for all the values where a cosine's negative 1 divided by the square root of 2, and cosine's only negative in the second quadrant and the third quadrant. So again, we can form right triangles that have adjacent side of length 1. The hypotenuse is the square root of 2. And the acute angle formed with the x-axis is theta. So by symmetry, we can make another triangle in the third quadrant with all the same values. And so the thing that we found right here is that this side should also have length 1. And so the angle over here is also going to be given by, our angle theta for both of these is going to be pi divided by 4. So theta in both of these cases is pi divided by 4. But again, these are reference angles, so we need to go ahead and subtract pi minus pi divided by 4 for this one. And for this angle here, this is going to be given by pi plus pi divided by 4. Okay. So let me go ahead and just start a new page and we'll see what we have. So for part A, we found the solutions were either theta is equal to pi divided by 4, or theta was going to be 2 pi minus pi divided by 4. And then in part B, we found theta was going to be either pi minus pi divided by 4, or we had pi plus pi divided by 4. So let's go ahead and simplify these real fast. In this first case, theta again is equal to pi divided by 4, or theta is going to be equal to, what is that, 7 pi divided by 4? And in part B, we'll have, this is 3 pi divided by 4, or theta is going to be 5 pi divided by 4. All right. And now to find the general solution, we just add a plus 2 pi times k to each of these terms here. And these are going to be our solutions. Again, this corresponds to the kind of the positive values, and these ones correspond to the negative values. All right, but they're all solutions to our original equation. So any questions on this one? Yeah. So fundamentally, we're just trying to rewrite our trigonometric equation so it looks like the very first example. So that's basically the game, all these other problems. All right, so let's look at, I think this is example number 4. I could be wrong, but we want to go ahead and solve sine theta times cosine of theta minus 7 sine theta is equal to 0. And again, what we want to do is we want to think about this almost like a polynomial. And what we notice is that we have a sine theta in both of these terms. So we can go ahead and pull that sine theta out. So we'll get sine theta times cosine theta is minus 7 is equal to 0. And again, we have two different equations to solve. Either sine theta is equal to 0 or cosine theta minus 7 is equal to 0. So sine theta is equal to 0. This only happens either when we have theta is equal to 0 or when theta is equal to pi. So this comes again from the unit circle definition. So two particular solutions to this sine theta is equal to 0 is, again, theta is either equal to 0 itself or it's equal to pi. So we'll go ahead and look at the particular, or the general solution in a second to this. Well, let's go ahead and look at part B real fast. So part B, we add a 7 to both sides and look, cosine is equal to 7. And this tells us we have no solution to this side over here. So why does this tell us we have no solution? Yeah, so it's not on the unit circle. Another way to put this is that cosine can never be equal to 7 because the range of this function is between -1 and 1. And like you said, it's not on the unit circle. Where are cosines defined at? So I guess let me just go ahead and draw the graph. Cosine's always bounded between 1 and -1. So it's never actually going to hit 7. So this has no solution. So the only solutions to example number 4, again, are going to be theta is equal to 0 or it's equal to pi. Again, to find the general solutions, we just add a 2 pi k to 0 and we add a 2 pi k to pi. And this is our general solution. Okay, let's look at one more problem. So this is going to be example number 7. And we want to find all solutions of the equation -2 divided by the square root of 3 of cosine of 3 theta is equal to 1. So in this problem here, what we want to do is we want to just set 3 theta is equal to alpha and then solve this like we've done the other problems real fast. So we're going to be looking at the equation -2 divided by the square root of 3 times the cosine of alpha is equal to 1. Multiplying by the reciprocal of this number here, we'll get cosine of alpha is equal to the square root of 3 divided by 2 with the negative in front. So again, we want to find all the alpha values where a cosine has a negative square root of 3 divided by 2. Cosine, again, is only negative in either the second quadrant or the third quadrant. And so we can form our right triangle, whose acute angle is alpha this time. The adjacent side has length square root of 3, and whose hypotenuse is 2. And we can do the same thing for a triangle in quadrant 3. If we wanted to find the opposite side again, we just go ahead and use the Pythagorean theorem, and we'll get that a is going to be the square root of 4 minus 3 So this is going to be equal to 1. So this has length 1, this has length 1. And this tells us we have a 30, 60, 90 triangle. And remember, in our 30, 60, 90 triangle, if this has side 1, this has square root of 3, and this has 2, then this side over here is going to be given by 30 degrees. So our angle alpha is going to be equal to a pi divided by 6. And now the last thing to remember is that alpha is a reference angle for these two triangles. So alpha is going to be, the actual angle is going to be pi minus pi divided by 6, or equivalently, the other solution that we'll get is pi plus pi divided by 6. So let's go ahead and rewrite this on the next page. Our alpha values we found are going to be either pi times 5 divided by 6 or 7 pi divided by 6. Okay. And so really, we're at the last part of this problem. We're going to go ahead and replace alpha with a 3 theta, since that's what we did at the beginning here. So what we have is that 3 theta is equal to 5 pi divided by 6, or 3 theta is going to be equal to a 7 pi divided by 6. And so now what we want to do is just go ahead and add your 2 pi k to each term here, since this is going to give us our general solution, and then multiply both sides of this equation by 3. So we're going to get theta is equal to 5 pi divided by 18 plus a 2 pi k divided by 3, or we'll get theta is equal to a 7 pi k divided by 18 plus a 2 pi k divided by 3. And so these are going to be the general solutions to our problem. And that's it. Okay. I think this is a good place to stop. If you do have more questions, feel free to ask or send me an email. We'll also be here for another 45 minutes, so we can go over more problems if you want, but that is up to you. So let me stop this recording real fast.